In this video, we're going to go over how to rederive most of the trig derivatives as a backup plan in case you forget them. So let's jump in. Now here, I'm going to assume that you've already remembered the derivative of sine and that you've maybe forgotten some of the other ones. If you do forget the derivative of sine on a test, I would say you're basically in trouble. So you do not want to do that. Now, just to be clear, you can rederive the derivative of sine. It just takes a lot more work. It takes so much work, actually, that I don't think it makes sense to do on a test. Basically, what you would have to do is rederive it from the limit definition of a derivative, and then you'd have to use a sine double or sine angle sum identity, and then two special trig limits, which is a ton of work. So I don't recommend doing that. Instead, I recommend remembering sine and then remembering certain tricks to get all the other ones in case you forget those. And honestly, you should try to remember all 6 of these trig derivatives for speed on a test. In other videos, I've covered specific cases of if you remember the derivatives of these 3 on the left, there's a special pattern you can recognize to get to these 3 on the right. However, that kind of begs the question, what if you forget some of the 3 on the right? So we already talked about you don't want to forget the derivative of sine of x, but what if you forgot, say, the derivative of secant of x or tangent of x? Well, then that method would break down. That's why it's useful to have a plan B in case you do happen to forget 2 of these. So that's what we'll talk about in this video. Basically, the trick that we're going to rely on here is the fact that you can think of all trig functions as a ratio of sine and cosine, sine and or cosine, I should say. So, and think about that. Every function is either a ratio that has basically sine and or cosine and or 1 in it. So like sine is sine over 1, cosine is cosine over 1, tangent is sine over cosine, secant is 1 over cosine, tangent cosecant is 1 over sine, and then cotangent is cosine over sine. So every single trig function you can represent in terms purely of sine and or cosine. So basically what we're going to do here is rederive those derivatives by representing them first as a function of sine and cosine, and then again, if we remember the derivatives of sine and cosine, we can get to the other ones. So that's what we're going to try with secant. Let's get started. How can we write secant as a function purely of sine over cosine, or sine and or cosine, I should say? Well, basically, this is where being aware of your trig identities comes in handy. Secant is 1 over cosine. So you can look at the derivative of secant as the derivative of 1 over cosine. Now, what is this? We have one thing divided by another thing. That's the chain rule. So how would we use the chain rule, or sorry, the quotient rule? You could also think of it as a chain rule with negative exponents, but I won't go there. The easiest way probably is to use the quotient rule. So remember what the quotient rule is. I'll just mention this over here. And again, I'm going to be a little lazy with how I write this. But if you have some function f over x and you want to take the derivative, it's basically the derivative of f times g minus f times the derivative of g, all over g squared. So here, the way we're looking at it is that f is 1 and g is cosine. So what's the derivative of 1? 0 times cosine, so this term won't even matter anyway. So that's like f of g. And then minus, it'll be f, which is 1, times the derivative of cosine, which is, think about it, what's the derivative of cosine? Negative sine. Negative sine of x. So we have that, and then basically what we can think of down here is what is cosine squared. We'll just leave that there for now, cosine squared. So we have that, and then what can we do from here? Basically, to work it down, again, I'll simplify. Remember, this term goes to 0. This will be positive sine, so you can really think of this as positive sine of x over cosine squared of x. Now, you can consider this completely done, but usually we simplify it a bit further. A special trick a special way that you can look at it is, instead of thinking of it as sine over cosine squared, separate the different cosine terms. So think of it instead like this: sine of x divided by 1 cosine times 1 over the other cosine. And then if you think about this, what is this? Well, sine over cosine, we know that's tangent. And what's 1 over cosine? We know that's secant. So there we go. That's how we can derive the derivative of secant. So that's how we can rederive the derivative of secant. How can we now rederive the derivative of tangent? Well, with the derivative of tangent, we can look at that as, think about your trig identities. the derivative of sine over cosine. So sine of x over cosine of x, and we basically want to take the derivative of that. Again, we're going to use the quotient rule here because we have a quotient, one thing divided by another thing. So what's the derivative of sine? Cosine. So that's like f prime times g cosine minus f, which is sine, times the derivative of cosine, which is negative sine. And then all over cosine squared, all over g squared. So we have this. Now, again, it might not be crystal clear how we can simplify this. There are a couple ways that we could do it, but the simplest way is if you notice this certain trig identity. If I rearrange this, the two negatives cancel out, so the numerator becomes cosine squared plus sine squared of x over cosine squared of x. And again, you might be tempted here to divide both of these terms, like, so in other words, divide both of the numerator terms by cosine squared of x. That will lead to a true statement. But the better thing to do is actually just to notice the entire numerator can be replaced here with a certain trig identity. Remember, cosine squared of x plus sine squared of x just equals 1 for any x value. That's the Pythagorean trig identity over cosine squared of x. So there we go. And we simplify it further to say that this is equal to secant squared, if you want to look at it like that. So the derivative of tangent is secant squared, in other words. Now, the other two trig identities that we didn't, or the trig derivatives that we did not get to, cosecant and cotangent, follow almost the same procedure that we had here. It's just that cosecant is going to be 1 over sine rather than 1 over cosine like we did before. And cotangent would be cosine over sine rather than sine over cosine like we just did. But otherwise, they're basically the same. So this is how, if you've already remembered the derivatives of sine or cosine, you can rederive the other four, basically, in case you forget them. Again, it does take a little time on a test, but this is a pretty good backup plan. So that's what I would recommend. So there you go. You have to be a little clever to use these methods, and you have to remember your trig identities, but hopefully this all makes sense. Catch you next time.